Okay, this is video 2 of 1.1 notes. It's the second page. So in each of these graphs, we are wanting to identify the function family to which it belongs. We want to draw in the parent function, compare the graphs, state what happens, what kind of transformation happened, state the domain and range, and tell whether it's even, odd, or neither. Okay, so for number 1, it's a straight line, so it is linear, although, wait, it says, identify the family first, so we'll do that. So this one is linear. Okay, and if I draw in that parent function, remember, it goes through 0, 0 with a slope of 1, and I do want you drawing in exact points, okay? And that is the parent function, okay? Then it wants us to state or compare the two graphs, okay? So I stated the family is linear. Let's compare the two graphs by describing the transformation, okay? So the first thing I notice is that, well, my parent function is going from left to right. It's going up, has a positive slope. And this graph has a negative slope. So that would be a reflection because it's flipped. If I were to flip my parent function over, okay, over like the y-axis, it would make it go negative, okay? So it's a reflection because it's flipped. And you can even write that if you need. Okay. Then, if I were just to flip this graph, it's not going to match up exactly. So it also has to have this translation. And my parent function goes through 0, 0. But this one is actually has a y-intercept of 8. So it's going to translate up 8. So it moved up 8. Okay? And then we look, well, even if I flipped it and moved it up 8, they're still not quite going to line up because my parent function is quite steep where the graph I was given is quite flat. So this is a vertical shrink because that parent function is flattening out. I don't know what I'm writing. It's a vertical shrink because it flattens. All right, and then it wants us to state the domain and range. So our domain are all possible values of x of our graph. So the domain here, it goes to the left forever, it goes to the right forever. So x can be absolutely any number. So it is all real numbers. Okay, then the range are the values that y could be. Well, again, it's going up forever and down forever, just doing it kind of slowly, but it's still getting there. So it's all real numbers. And then it wants to tell whether this function is even or odd or neither. Okay, so to make a function even, if I were to reflect it across that y-axis, is there some form of symmetry? And when we get to graphs, once we start having quadratics and higher powers, there's another way that helps us remember this. But for linear graphs, we have to look at, if I were to reflect this over the y-axis, so reflect it all across this, so this would scooch here, is it the same? And in this case, it's not. So this one would be an odd, it would be an odd function. So this would be an odd function. Okay, so graph number 2, I'm going to have to erase all of this to make room for graph number 2. We need to first identify this function. Well, it's going straight across from left to right. That is linear, but for the purposes of what we're doing in this packet, we are going to say that it is a constant. It is constantly one number. Okay, so that is the function family. If I draw the parent function, it's constantly forever, but it's constantly 0. Okay, and if I compare the graphs, well, this just has a translation. Translation because it's moved down 3. Okay, there's no other shifts that we can determine. So then if I state the domain and range, the domain is all values of x. It's going left forever, right forever, so it's all real numbers. But the range doesn't go up and down forever. In this case, y is always -3. Okay? And then we state if this is odd or even. Okay. This one is, because if I reflect it over that y-axis, it's the same on both sides. So this one is going to be even. Now, for all constants, that will always be even. All linear that aren't a constant will be odd. The only constant where it's going straight from left to right, y is one constant number, where it's not just even or odd is actually that parent function. And we consider it both to be even and odd. So you won't be counted wrong on that one if you just say it's even like the rest of the constants, but it is also considered odd. Let's do this third one. Okay, so we need to name its function family. And in this case, it's a v, so I know immediately that it is absolute value. And that's for this graph, sorry. Absolute value function. Okay, and if I graph the parent function, it is linear on one side. So if I start at 0, 0, and I go up just like I would for a linear function, but I don't go down, okay? I actually mirror it, because if you remember, absolute value just means if I take the absolute value of a number, even if it's negative, my answer will always be positive. So in this case, with these negative y's can't count, because it's distance from 0 on a number line, and that's always positive. A distance is always positive. So there's a parent function. So now I determine how did it go from that parent function to the function I was given. And in this case, it didn't translate, didn't move left or right or up or down. Both graphs go through 0, 0. So this one is, and it didn't flip. So this one is just stretching, gets narrow. So this is a vertical stretch. Because it narrows, okay? That's the only one. So then if we look for the domain, well, it's going forever left, forever right, so it's all real numbers. Okay, the range, it is not going forever up, forever down. It is going forever up, but it starts at that 0, and it does equal that 0, 0. It's at that point. So this would be y has to be greater than, but can equal 0. Okay? Because the y values can be 0 and every value above it. Okay? And then we want to state if it's odd or even. Well, if I were to reflect this across the y-axis, it will be even. So all absolute value functions are even. So linear functions are odd, constant functions even, absolute value functions even. Okay, so now if I go to the next part, this one wants you to graph the function and its parent function, describe the transformation, state the domain, odd, even, or neither. Okay, so you should be able to quickly draw in those parent functions. Oh wait, you got to draw the actual function first. I'm sorry. So if I were to figure out what number 4, its parent function. Okay, I can tell that's a line, y equals mx plus b. So I know my parent function is going to go through right there. Put exact points because I expect them to be straight across. On this iPad, I can't make it as straight as I would like. And then if I were to graph my new graph, I would graph this function. It has a y-intercept of -7, and you have to be very careful that you're getting your units right here. It doesn't count by 1s, it counts by 2s. And then you would have slope of 1, I got to put the points to be able to see it on this weird graph here. If I can connect the dots. Okay. So there's my new graph. Okay, so I graphed the function and its parent function. I want to describe the transformation. Okay, so this one is just a translation. Okay, so I can say it's going down 7, or you can also say it's moving right 7 because it is. I think it's easier to see based on that y-intercept what it's doing. The domain is all real numbers because it's going left and right forever. Oh my goodness, I can't spell. And the range, it's going up and down forever, so it's all real numbers. I did it again. Have I been doing that the whole time? That's funny. And then if it's odd or even. Well, I told you all linear graphs are odd. Okay, if I reflect it over that y-axis, it is not the same. Okay, number 5. If I graph that parent function, this is a constant, so its parent function is at 0, 0. Okay, graphing this at -9 is right here. Okay, so again, this is just going to be a translation. And I do like you to describe what happened. So in this case, it went down 9. Okay, the domain is going left and right forever, so it's all real numbers. Its range is only one value. It can only be y equals -9. That's the only thing y can actually equal. And if I mirror this and it's not at 0, y equals 0, this would be even because if I mirror it over the y-axis, it's the same. All right. Let's do number 6. So this is an absolute value. So I know, whoa, if I can be straight here. It's really hard with an iPad here. All right, there's my parent function. So I'm going to graph this one now. And that +1 on the end, it acts the same as the plus or minus on the end of a linear graph. Okay, that's moving me up or down. And so in this case, it's a +1. So I'm going to move up 1 and put a point. Okay, and then there's no other numbers to worry about. So it's going to be that parent function just moved up 1. So, but again, remember your units here. Although in this case, since it's going by 2s, we're good. So there. Oh, I missed. Okay, so this is just a translation. It just slid up. So it moved up 1. And I am realizing now my units were wrong. You got to be down between this, but I can't fit there. The domain is going left and right, so it's all real numbers. The range, y can be any number from 0 up. Nope, from 1 up, because 1 is where it went and started at. So y is greater than or equal 1. And then this would also be even because it reflects and is the same on both sides. All right, number 7 here. Oh, sorry. It's an absolute value. So I draw my parent function. Okay. And this one doesn't move. It doesn't have a plus or minus for me to plot a new y-intercept. But what it does have is this number in front of my absolute value. And what that means is basically it's a slope because absolute value functions have straight lines. So the right side of my graph, if you look at my parent function, it has a slope of 1, okay? So this having a 6 there just means it has a slope of 6. And if you remember, slope is rise over run. So I'm going to go up 6. If I go up 6 over 1, which is like right there. It's in between the lines, okay? So I'm going to go up 6 over 1 and put a point. That's now my vertex. And it's not my vertex, I'm sorry. From my vertex, I'm going to that point. But I don't go down that. I don't do that like if it was linear, okay? This is the absolute value 1. If I were to plug in a -1 for x and go left and go -1, it's still going to give me a +6, okay? So absolute value ones mirror. Okay, they don't go where y would be negative. Okay, because absolute value means you get a positive number. Unless my multiplier is negative, but then I wouldn't have positive y values, because if my multiplier was negative, it would be flipped over that x-axis. Okay, so in this case, my transformation, it does not translate. It's not moving left, right, up, or down. It is not rotating. It is only doing a vertical stretch. Okay, it's getting skinnier and taller. Okay, my domain, again, it's going left and right forever, but just doing it slowly now, but it's still going that way. So all real numbers. And then my range, y can't be negative in this case, so it's going to be y is greater than or equal to 0. And then even or odd, it will be even, because if I reflect it on that y-axis, it is the same. Okay, so there's another video to continue to the last page of these notes.